Hello, this is Eric. Thanks for watching this first full flight demo of my cable leakage detection drone. The purpose of this flight is to demonstrate on a small scale the efficacy of using a small aerial vehicle drone for leakage detection and geolocation. I believe it is possible to precisely locate cable impairments on a wide scale using small unmanned aerial vehicles. The airframe is a Pixhawk 4 based development kit from Hollybro. The payload consists of a Comsonics QAM Compass digital leakage detector and an iPhone SE running the Comsonics MPL app. The telemetry and control system is a hex HereLink, which I will explain the significance of later on. Today we'll be attempting to locate a -8 dBm leak, which is less than 1/10 of 1 milliwatt, generated by a Comsonics M3 signal source. The first test was a control, walking around with the QAM compass in measure mode. As you can see, it is picking up the signal clearly as I walk around the source. Please note that I wasn't necessarily attempting to hone in on the leak, only attempting a semi-grid walk. Given the non-linear nature of the antenna, which is roughly a full wave loop but not checked closely for SWR, it does show some directionality in the signal. But for the most part, I was able to find a peak without much effort, especially consider when the meter's assumed distance was set to 10 feet. The test flight's flight plan was fairly simple. Manually fly in a basic grid pattern while observing the leakage detection meter response. Given the extremely low level of the signal source, I set the meter distance to 75 feet, which increases the sensitivity to low signals. The first pass was to be done at 15 to 20 feet. Then, depending on the outcome, ascend to 30 feet and then 75 feet, time permitting. After completing the pre-flight checklist and arming the aircraft, I set the flight mode to loiter, which will instruct the flight controller to maintain location and altitude and smoothly respond to inputs from the pilot. I then began flying a rough grid pattern around the field. The video on this screen is from a stationary camera on the ground. The aircraft has no camera at this time in order to save weight. As you can see, right away we have detected the leak to within a few yards of the source, which is mid-field. I should note that the MPL application does include a function to log leaks with GNS data from the iPhone. However, it only functions when monitoring for actual plant faults, not using the M3. The next test will be on live cable plant, comparing traditional drive out to fly out, but there are still a number of bugs to work out before that can occur. At this point, I wanted to see if I could accurately hover over the source using the Quam compass feed as a guide. The reason why I chose the Hex HereLink transmitter and telemetry system is because it is capable of supplying an Ethernet bridge across the link for payload telemetry. I had tried using Wi-Fi and tethering for payload telemetry with very poor results. The HereLink, which runs Android OS, will accept supported USB to Ethernet adapters using OTG cables. When this feature is enabled, it will transparently bridge between any two Ethernet devices using the high reliability of the control and telemetry lead, which has been rated to operate over several miles line of sight. Using screen sharing on the payload iPhone and a program called Reflector 4, I am able to monitor the meter while flying, although I can't control it due to restrictions in iOS. The aircraft is also supplying telemetry data from the flight controller using a program called APM Planner, which can also be used to load pre-planned missions into the autopilot for fully autonomous flight. As a final test, I dropped my altitude to 5 feet just before landing in order to see how much of a peak I could generate. This would not be a normal use case for the system, but it does clearly show that it is a relatively easy way to correlate distance and signal strength from using the autopilot telemetry. By the way, the MPL application expects to communicate over the internet, given that there's no internet connectivity over the Ethernet telemetry, it came up with this error. This is somewhat expected.